All right, let's look at 6.7. So 6.7 is negative exponents, quotient rule powers, and scientific notation. So negative exponents are probably the trickiest part of the lesson. If you recall in class, we sort of built out why these work the way they do, just sort of looking at the pattern of how exponents even work. Let's simplify each of these. So x to the negative 3, I'll give you the pattern here. Whatever the base is, we just flip it, and that changes the sign of the exponent. So it's going to be 1 over x cubed. What about number 3? Number 3, we have 2a to the negative 4th. This is just going to be 2. Now, the question I always ask is, what is being raised to the negative exponent? In this case, just the a. So the a is the only thing that moves to the bottom. So the negative exponent, in one sense, it just shifts the base from the top to the bottom, or if it's on the bottom already, it shifts to the top. And that's it. That's as far as you can go. It's sometimes easier to work with positive exponents. Now, I'll be honest, it's sometimes easier. You actually be converting things to negative exponents because it's easier to have everything on the same plane. What about number 5? So number 5 here, the question is, what is being raised to a negative exponent? And that's what gets moved. So the m is the only base that's being raised to a negative exponent. And so the n stays the same, n cubed over m squared. Now you can guess a very popular and attractive distractor on this would be as if they both move downstairs. But again, the only one being raised to a negative exponent is the m. That's the only one that moves. What about number 8? So number 8, we do have negative exponents here, and you've got an option. You can go ahead and apply this exponent out here to everything and then move, or you can move and then apply it. It doesn't really matter. Let's go ahead and apply this exponent first. So 2 squared is 4, and then p to the negative 4, q to the 6. So we learned that in the last lesson. We just multiply exponents together whenever exponent's being raised an exponent. And now we want to write this with no negative exponents in our final answer. So the question is, what is being raised to a negative exponent? Just the p. So that's the only one that's going to move. So 4q to the 6th all over p to the 4th. Okay, so we've learned this property before, I believe, when we had this, but now we're going to have a chance for the exponents to be negative. And we want to go ahead and rewrite these with positive exponents. Okay, so how about number 10 and how about number 13? No rhyme or reason why. I mean, there is a rhyme and reason. I'm trying to choose one that's sort of easy and then one that's maybe a little challenges a little bit. So b cubed over b to the 8th, what's that going to be? B, we're going to subtract these, and we're going to get b to the negative 5, or 1 over b to the 5th. Now, what you can do, I mean, once you start doing these a few of these, you can see that, we can kind of subtract backwards, and we know it's going to be in the denominator. So there are all sort of tricks on these. And again, think about why this works. What is b cubed over b to the 8th? So b cubed are b times b times b over b to the 8th, which are 8 of those b's. B, 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 and then 1, 2, 3, 4, 5. And what happens? Well, these b's cancel, and I'm left with 1 over b times b times b times b times b, which is 1 over b to the 5th. How about 13? So 13, we have a coefficient here of 4 and a coefficient of 2. I personally go ahead and do those first. So 4 divided by 2 is 2. 2. And then we can say A, 7 minus 3 is 4. B, 2 minus 5 is negative 3. Now, what you could have done is said, well, I know that 3 is going to be in the bottom. I'm showing you 2 steps because this is sort of how the formula is set up. So we get 2a to the 4th over b cubed. And I have more than one part. It's always good form to go ahead and circle your answer. Now, scientific notation. So scientific notation, again, allows us to write really, really big numbers and really, really small numbers in a nice compact way that makes it easy to compare and to talk about. I don't give you anything that's really too big here, so maybe that point gets lost on these problems. But let's do we'll do 16 and we'll do 19. And then over here, I'll do 1 negative and 1 positive. How about 21, 22? So here we've got a really small number. So I know I'm going to be multiplying times 10 to the negative something. So this is going to be 5.6 times 10 to the negative, and then I'm going to count. Got 1, 2, 3, 4 to the negative 4. And again, we always have some number between 1 through 9 here, point where however many decimals will go out, and then times 10 to the, and then if it's positive, if it's negative, if it's really small number, it's negative, really big number, it's going to be positive. So let's look at this one here. So we're going to have 6.7. And so the question is, how many times did I move it? I've got 1, 2, 3, 4, 5, 6, 7. So times 10 to the 7th. Now what about over here on 21, 22? Now we're going to be going back to decimal notation or standard notation. So I've got 7.5, and then I'm going to move the decimal point over how many places? Good, 3 places. This is going to be a really small number. So we're going to do 1, 2, 3. Now I just fill in zeros there, put my decimal. I like a leading 0. It just makes it easy to see. And then for the final answer, we usually don't put those little bloops. I'm going to write it down. What about 1.09 times 10 to the 6th? So we got 109. And I moved this decimal point over 6 places. So 1, 2, and then 3, 4, 5, 6. Good, put commas in here. So 1,090,000 would be the answer for that. I'll be honest, when I'm doing numbers that are super small, I'll sometimes put spaces when I have those, and I think I did that in the classwork that we did in class. So here's sort of mixed exponent rules. Maybe I'll do a few that we didn't quite, maybe didn't get captured in the earlier ones. Oh, I don't know. How about number 29, 30, 36. Oh, 44 looks pretty hard. 43 is sort of a sleeping giant there. And then 46. We'll do these right here real quick. So number 29. If all you're doing is watching the video, it's not really going to help you as much as you think it does. It makes you feel good because you're watching the video and I'm leading your brain through. It's super important that you're doing these. So sort of mixed practice with all the rules we've been doing. I tried to get at least one of each type. Okay, so 2 cubed is 8. Then x cubed cubed. Remember, we're multiplying exponents. Y squared cubed, y to the 6th. Now what about number 30? So 30, I have a chance to combine these. So p to the negative 2 times p to the 5th is p to the cubed. Why? Because 5 minus 2 is 3. I'm adding those together. And similar here, q 3 plus negative 1 is 2. Now, if any had come out negative, I would go ahead and take care of that. What about 36? This one's also a little tricky. You've got to be careful with your signs. Now, one recommendation is to go ahead and change everything to positives before you begin subtracting. It's certainly up to you. Using sort of the letter of the law that were our properties, we're just going to do m. We have negative 4. Now, maybe I'll write this out. Negative 4 minus 2. And then n to the 2 minus 5. So when I'm dividing, I subtract the exponents. Plus a negative, and then I'll have m to the negative 6th, n to the negative 3. But we don't want to leave these with negative exponents, positive exponents only. So we got to go one more step. They're both being raised to a negative exponent. So it's 1 over m to the 6th, n cubed. Now, let me show you another way we could have done that. I have m to the negative 4, n squared over m negative 2 into the 5. It's sometimes worth it to go ahead and just change my negative exponents to positive. So that's negative, so it's going to go up. This is positive, it's going to go down. So I'm going to have m squared over m to the fourth, n to the fifth. Now I can subtract, or another way to think about it, I mean, I could subtract 2 minus 4 is negative 2, 2 minus 5 is negative 3, but then they drop back down. So you could almost subtract up and down, right? And so we know this is going to be m squared n cubed. 4 minus 2, 5 minus 2, and we know it's going to be downstairs. You didn't have to do it that way. You could have done it the way we have been doing it and just say m to the 2 minus 4 is negative 2, 2 minus 5 is negative 3, and then convert it to that. So there are a bunch of ways to think about these. Just make it make sense to you. Don't just memorize. Make it make sense to you. And the only way you can do that is by working some practice problems. If you're coming to class and not doing any practice problems, it's going to be really tough. Let's do a few more in there. Number 43. This one is highly missed. So be careful on this. Again, you got two options. You can go ahead and subtract 6 minus negative 2. The students really miss that a lot, even in the calculus sequence. They will miss that, so really be careful. 6 minus, I'll even write this out, 6 minus negative 2 is k to the 8th. Now, another way to think about that is to sort of use that same strategy we just did, and that is go ahead and convert before you begin to add or subtract, particularly subtracting. We can go ahead and convert this to a positive exponent. So that's just going to shift up, k to the 6th times k squared, because that's a positive negative exponent. To make it positive, it just goes up. And now we're just going to add, and adding does not usually provide the same level of difficulty as subtracting does. K to the 8th. We get exactly the same answer. Again, I don't care which way you do it. Make it make sense to you. Okay, two more here. So I'm going to first go ahead and divide. So 4 divided by 2 is 2. 3 minus negative 1 is to the 4th. Now, if I'm doing this, I can go ahead and see that b to the negative 2, I'm going to slip it down to the bottom. It's going to be b squared times b cubed to get b to the 5th in the denominator. You don't have to do it that way. But I do notice when students start to subtract, they mess up. So negative 2 minus 3 is negative 5. And then we rewrite that to a to the 4th over b to the 5th. And then last one here, it's kind of multi-step here. We first need to do what? What's in the parentheses? Go ahead and exponentiate that. I'm going to have 2 squared is 4 p to the 4th q negative 6 all over 4 p to the 5th q. So what happens to those 4's? Those 4's cancel. I'm going to get p to the 4 minus 5 is negative 1. Q, and this is negative 6 minus 1 is negative 7. And then these are both negative, so they're both going to go downstairs. So p q to the 7th. Very tricky. These are very technical. Make sure you can do them, though, and it's going to take practice to get through these. Hope that helps.